Okay, moving on to the large intestine. Our large intestine doesn't do a whole lot. There are some important functions. We've accomplished most of our digestion of our macromolecules in our small intestine, along with water. When we're talking about our large intestine, we're going to finish absorbing some water. We might have a little bit more digestion occurring, but that's going to be accomplished by the bacteria that are residing in our large intestine. Also, our large intestine is going to help get rid of and eliminate feces, basically, which is all of the products we were unable to digest. So let's just kind of go through the anatomy, the gross anatomy of the large intestine. The first part of the large intestine is the cecum. The cecum is what's going to be connected to the ileum, or the last segment of our small intestine. The appendix is adjacent to it, and this is just a mass of lymphoid tissue. It is part of the molt, and basically it's going to store bacteria. We know it's susceptible to blockages. I know you probably know somebody who's had appendicitis, or you might yourself might have had appendicitis. Our other regions are going to include the ascending. So after our cecum, we have our ascending colon, transverse colon, which is going directly across, our descending colon, which is going to ultimately end at our sigmoid colon down here. So just a little bit about appendicitis, because it is fairly prevalent in society. That's when you have acute inflammation of your appendix, and again, resulting from some sort of blockage. Usually it's feces. And if we have a blockage in our appendix, it's going to trap that bacteria. If you have appendicitis or inflammation of your appendix, you're going to be unable to empty the contents, and your appendix is going to swell, which isn't going to allow for venous drainage. If you have a ruptured appendix, it can lead to peritonitis. Symptoms, typically you have it in your lower right abdominal quadrant. You can also have loss of appetite, nausea, vomiting, and pain. Treatment, appendectomy, completely removing it. In some cases, if it's not severe, you can go in and treat it with antibiotics. So that brings us to the bacterial flora. So really, really important is the bacterial flora that's residing in our large intestines, which we also call the bacterial microbiota. It consists of over 1,000 different types of bacteria. And some of these bacteria can colonize the colon all the way through. And how do they get there? A lot of times is through the anus. They can also enter in from the small intestine, and they have a lot of very important functions. One of the important functions is fermentation. So some of the indigestible carbohydrates that we're intaking, as well as mucin, they're able to ferment those and break those down. One of the downsides of fermentation is the production of gas. So the processes of our bacteria breaking down all these indigestible products can cause us to release gas of around 500 milliliters a day, depending on our diet. Another really important metabolic function of our bacteria flora that's residing in our large intestine is synthesis of vitamin B complex, as well as some of the vitamin K that the liver needs in order to produce several of the clotting factors are actually synthesized by gut bacteria. So because we have so much bacteria that are living in our small intestine, we have to make sure that we're keeping the ones that are harmful to us, or the pathogenic bacteria, kind of in check. So there's two ways in which we can do that. The beneficial bacteria tend to outcompete and suppress the harmful bacteria. So we have huge numbers of those. Second, our own immune system prevents bacteria from entering the body through the gut epithelium. So this kind of system keeps bacteria from breaching the mucosal barrier. There are some benefits, huge benefits to gut bacteria as well as our health. There's evidence finding that the kinds and the proportions of gut bacteria can influence, one, your body weight, susceptibility to various diseases, including diabetes. Now they're looking at studies of the bacterial flora in your large intestines in correlation with diabetes, atherosclerosis, as well as fatty liver disease, and our mood. Like I mentioned before, it's called our gut brain connection that can be influenced hugely by what type of bacteria and how much of that bacteria are present in our large intestines. Another kind of thing I want to point out is antibiotic-associated diarrhea. This actually accounts for about 14,000 deaths per year. So the main cause is going to be Clostridium difficile. This is an anaerobic bacteria, meaning that it doesn't require oxygen, but it's not harmed by oxygen. And they're found in our intestine. So C. diff is going to be the most common cause for this type of imbalance. What happens is when you take an antibiotic, you wipe out not only the bacteria that you wanted to get rid of, but you also wipe out other beneficial bacteria. So when you're wiping out the bacteria that you wanted to get rid of, as well as the other bacteria that are residing in your large intestines, it can cause C. diff to go in and flourish, which can end up leading to inflammation if you have too much C. diff in your large intestine. Nowadays, there's huge amounts of resistance from this type of bacteria, so you have to go in and treat it with other mechanisms. One of the newer mechanisms, which sounds really gross, but they're actually doing a lot of studies, is fecal transplants. So what they're doing is collecting basically the microbiome of the large intestines of a healthy patient, and they can test that. If they're healthy, then they're going to take the feces from that one, transplant it to the unhealthy person, allowing exposure to the healthy bacteria, hoping that they will flourish. So digestive processes of the large intestine, basically we don't have any food breakdown like I mentioned. We finish that in the small intestines, except for what's actually occurring by the bacteria that's residing there. We do have some vitamins that are made by the bacterial flora that we want to be able to absorb into our bloodstream, along with any remaining water. Most of it is from our small intestines, but some water is still absorbed from our large intestines, and then important electrolytes that we need, like sodium and chlorine, can be reclaimed. And then we're just, again, if we're talking about the tubing, what the function of it is just to get the feces to the anus so that we can go to defecation. So when we're talking about defecation, really, we're not going to go into a lot of details, just what is it. We're talking about moving the feces towards the rectum and initiating the spinal defecation reflex. So this is going to be under parasympathetic or rest and digest controls.